Now we are heading towards the technical paper sessions we all are here for. All owing to its history, SP Pakistan section and PAPG exhibits its competency by providing platforms to both students and professionals to present their technical papers in the student and professional technical paper sessions. Similarly, this year, a total of 18 professional papers would be presented by the industrial professionals under the umbrella of Petroleum Engineering section. Presenters of these papers and the presentations would be divided into 5 main sessions covering the next 2 days. We promise that this gathering is worth to be thought-provoking, as the brilliant minds from industry and academia have got together to navigate the transition of energy in the landscape. Moving towards the rules, each session would be led by a chairman and a co-chair. Each presenter of the paper will be given a time slot of 20 minutes. This time slot is further divided into 15 minutes for the presentation and the last 5 minutes allocated for the question and answer sessions. As a reminder of time, the chairman and the co-chair would be given an authority to ring the alarm bell to inform the presenter for wrapping up its presentation and starting of the discussion session. Owing to the restriction of time, we request all the presenters to adhere to their allocated time slots. Now we rush towards the session 1 of the technical paper sessions. In the first session for today, 5 presentations in technical forum will be presented. The professional presenting the presentations will be associated from multinational companies such as United Energy Pakistan Limited, PG&IG Pakistan, Pakistan Petroleum Limited, Sprint and ML Group Pakistan. This session would be chaired by Mr. Sayyid Shariq Ali Hashmi, a name well known. He has been associated with oil and gas industry for last 25 years. With his academics, he holds a master's degree in petroleum engineering from King Fahd University. Prior to this, he holds a bachelor's degree in mechanical engineering from NED University, Karachi. Currently, he is working as the head of development at Pakistan Petroleum Limited. Besides PPL, he has also worked with BP Pakistan, ENI Pakistan, Pakistan Refinery Limited. Having his expertise in reservoir engineering, he has served the oil and gas industry as various capacities, like Adi Field Head, Dog Sultan as in charge of Sui Gas Field, Manager Purification Plant, and the Chief Reservoir Engineer as well. Sayyid Shariq Ali Hashmi, sir, please join us on stage. Joining him will be the co-chair for us today is Mia Akram. He is serving as the Manager Reservoir Engineering OGDCL. He has a petroleum engineering graduate from University of Engineering and Technology, Lahore. He has been associated with oil and gas industry for last 31 years, holding a multi-dimensional experience in northern fields as well as workovers and enhanced oil recoveries. Mia Akram, sir, please join us on stage. So we have both our chair and co-chair bodies on the stage. So without further ado, let us start the first session. The first paper which is going to be presented today holds the title, Optimizing Well Placement and Recovery in Mature Gas Condensate Reservoirs through the Utilization of Pseudo-Pressure Approach. The paper will be presented by Sir Saad Mahmood. He is serving as the lead reservoir engineer from United Energy Pakistan Limited. Sir Saad Mahmood, sir, please join us on stage.
ये साइड से मूव अप एंड डाउन Assalamu alaikum everyone. I'm Saad Mahmood from United Energy Pakistan, and I'll be presenting you a case study of a field. And the title of the presentation is Optimizing Well Placement and Recovery in Mature Gas Condensate Reservoir with the utilization of pseudo pressure approach.
Saad, you will have 15 minutes to present. After 13 minutes, I will give you a bell to wind up your presentation, and then we will have a 5 minutes for question answers. Please proceed.
Thank you. So this is the outline or the agenda of the presentation. I'll go through the background of the field, the challenges that we face for gas condensate reservoir and its modeling. Then I'll briefly touch upon the generalized pseudo pressure approach. Then I will go through the static model, what PVT we have embedded in the model, then the sector model sensitivities. I'll explain why we did that. Then we have the history match optimization, so it is spots identification. Then we developed some forecast scenarios, and we later compared those forecasts with the actual data in order to establish the reliability of the technique. And I'll conclude with results and then the conclusions. So this is the field background. It was discovered in 2003. The primary reservoirs are 4 sands, sand 1, 2, 3 and sand A. Commercial production was started in 2013. It's a near critical gas condensate reservoir with an initial CGR of 120 barrels per MMSCF. The initial pressure was in the range of 5,300 and dew point was in the range of 4,900. So it's quite close to the initial pressure. Initial estimate, volumetric estimate is 150 BSCF. Cumulative is around 50 BCF. The drive mechanism is depletion to weak water drive. So there is no significant pressure sustenance. And currently there are 3 producers in the field. The challenges that we face in gas condensate reservoirs and its modeling. We know that the typical recoveries for a gas condensate reservoir is in the range of 40 to 60 produced optimally. The significant issue in gas condensate reservoirs is when we deplete or when we produce it, the pressure drops below the dew point and the dropout occurs particularly in the near wellbore region where there is a significant sink. And that hampers the productivity of the well, particularly the gas relative permeabilities. So the liquid dropout causes its mobility to reduce as well, which in turn provides low condensate yields and hurts the revenue of the field. So in order to have the reliable forecast of the field, we need rigorous computational compositional modeling in gas condensate reservoirs. And it could be quite time consuming. So I'll explain how the pseudo pressure technique optimizes the time as well as the results in simulation. So this is the generalized pseudo pressure approach. We know that in gas condensate reservoirs there are primarily 3 regions. One is closer to the wellbore in which there is simultaneous gas and condensate flow. Then we have a region of significant condensate buildup, and then the single phase region, which is closer or above the dew point. So as I explained that near wellbore, the productivity is deteriorated, and in order to model it, if we model it with a coarse grid, it is not adequately modeled, the condensate dropout within the reservoir. So we need to divide the coarser grids of our simulation model in smaller grids through LGRs, local grid refinements. And that models the condensate dropout, its associated drawdowns, and the impact on gas deliverability. However, we have a generalized pseudo pressure approach which accounts for this decreased mobility around the wellbore. It mimics the condensate dropout without using the LGRs and provides quite reliable results as well. How it does that? It basically divides the flow equation from the wellbore flowing pressure to dew point and then to the reservoir pressure. So it mimics all the 3 zones and captures that condensate dropout and its impact on the gas deliverability. So we built the static model, we populated the porosity and permeability, calibrated at well levels, and then we divided the model, the facies were populated, and based on permeability, there were 3 categories of good, fair, and poor. Of course, there were associated properties were populated according to them. Then the PVT was embedded. We had a third-party consultant which matched the PVT model, and we embedded that calibrated PVT into our simulation model. Then we did the sector model sensitivity. It was a very important work of this study, that we considered a sector model, not the full field scale simulation, in order to evaluate which technique is providing reliable results within a reasonable time. So we did 3 iterations with a coarser grid, with LGR, and then using the generalized pseudo pressure approach. So in pseudo pressure approach, we saw that it provides the most reliable results and with slightest increase in our computational time. So as you see, LGR time was almost 11 times higher than the coarser grid. However, the GPP time was around 1.5 times. And if you see the match, the coarse is providing quite optimistic results. Even LGR is providing optimistic, but pseudo pressure is the most conservative. So it provides the results closer to the actual data, and it saves time as well. So once we have this sector model sensitivity done, then for the full field scale simulation, we only use the GPP approach. So this is the history match optimization that we did using the GPP technique. And in order to achieve the history match, we tried to change several parameters, including the transmissibility multipliers in the X, Y, Z direction, the relative permeability of the rocks in order to match the gas and condensate forecast or actual data of the gas and condensate. We played with the fault transmissibility, and we did the sensitivity on the size of the aquifer. So this is the history match. You can see P1 and P2 well, and on the subsequent slides there is history match for the other wells P3 and P5, which are quite reliable, quite close to the actual data. Then we did the sweet spots identification. One way of doing or evaluating the future opportunities is to place well according to your understanding, and then have the sensitivity runs. So we avoided that because there could be several well locations we could have attempted in our forecast. So what we did the sweet spots identification. We generated the average maps for gas saturation, oil saturation, water saturation, and pressure. And based on understanding of the field, we created a workflow for the sweet spot identification. We created these cutoffs according to our understanding and of this field. With these cutoffs, we could have a well location that could provide good results, or it would be a successful and commercially viable opportunity. So we use these cutoffs: gas saturation of 0.5, SO less than 0.2, SW less than 0.4, some cutoff for permeability, and then pressure. So what it did, in the workflow, the simulator assigns a 0 or 1 value to that grid block. If the criteria is met, it would assign a 1 value. If the criteria is not met, it would assign a 0 value. Then we generate the average map for this using the simulator, and we get the average of all the grid blocks at that position, and this generates this map. So the highest value we get at O1 opportunity, where O1 is written, and the next potential opportunity was O2. So this is the maximum value we got, and we run the forecast on these locations in order for the potential future opportunities. So we did the NFA case, and then the NFA plus the future wells. We saw that GPP technique was providing a conservative forecast or the realistic forecast, while the LGR case was not used for the history match, subsequently not used for the forecast, but we did the forecast with the coarser grid, and it was optimistic as we discussed earlier. Then later on, we did the forecast comparison with the actual data of the existing producer. And it shows that the forecast from the coarser grid was quite optimistic, and the forecast that we get from the pseudo pressure technique was quite closer to the actual data. So it validates the application of the technique. And these are the results for the new wells that we forecasted for O1 opportunity. We have the gas and condensate forecast. So the results show that GPP could model adequately the gas condensate dropout and its impact on the gas deliverability and condensate deliverability, and provides a reliable forecast. The new opportunities would result in potential increase of around 10 to 12% recovery, and it's planned to progress with O1 opportunity first. It was more potential, and subsequently we would recalibrate the model for the O2 opportunity. So these are the conclusions. As I have elaborated earlier as well, that GPP provides the adequate or the more reliable forecast over the conventional techniques. It could easily be incorporated in our simulators. The simulators have the option, the commercial simulators, to use the GPP approach, and it captures the production impairment adequately. It's faster as compared to other conventional techniques that are available, particularly LGR. The workflow that we use for sweet spot identification significantly reduce the time for the forecast scenario. Otherwise, we would have iteratively doing the process of well placement optimization. So these are the two techniques, and that would add around 10 to 12% of the recovery in this gas condensate reservoir. Lastly, I would thank for the support of Subsurface Department of United Energy Pakistan, our other stakeholders and joint venture partners for their full support in our study, in our modeling and publication of this work. Thank you.
Thank you. Let's open the floor for questions.
Assalamu alaikum.
Walaikum assalam.
From OGDCL. What is the recovery for the base case?
Base case is around 40%, and we would be increasing around 10-12%. So we would be going above 50% with this, with these two new opportunities.
From drilling of both the wells?
Yes.
Okay.
Kindly introduce yourself first and then.
Assalamu alaikum. Jawad Ahmed from MOL Pakistan. What recovery factor are basically average recovery factor in this area where you're operating for gas condensate?
So it's as I highlighted also, the average recovery factors in this area is around 40 to 60%, and we in the base case we had the 40% because of the optimizations that we have done, and with these two new opportunities we would be going to the 50%. If we would have implemented some techniques earlier, we could have achieved slightly higher recoveries as well.
Don't you think this is a relatively less recovery factor for gas condensate field in normal porosity permeability reservoirs?
So generally it's in this range because it's a depletion to weak water drive. If we have a stronger aquifer support, the pressures would have maintained and we would have higher recoveries. But in this field, the pressures are depleting. There is no significant aquifer support available. Because of that, once it depletes, it causes a significant condensate dropout. And the per well drainage or the recoveries are not significant for that purpose.
Any other question?
But in gas cases, gas reservoirs, normally, a strong aquifer support can be quite detrimental, for the recovery.
Sir, basically when we have relatively higher aquifer support, it mitigates or there is less condensate dropout. So the gas effective or relative permeability is not affected significantly. In this case, the condensate dropout causes the condensate yield to be significantly reduced, as well as that dropout causes the gas recoveries to hurt. Of course, it would not go to a depletion drive gas reservoir of 80-85%, but it could be in the range of 60 to 70% for gas. But you would have significantly higher condensate yield, which would improve the economics of the field significantly.
The last question.
This is Numan from Halliburton. Question is so condensate dropout would be a function of more likely you are operating below the dew point, right?
Yes.
So do you think that changing the well placement practices in terms of well architecture, drilling longer wells, that would distribute the drawdown and that would help to have more pressure drop in order to produce at the same rates? Do you think that this kind of approach could also help you?
Yes, Noman sir, this is absolutely right, and we are currently initiating a study in which we are evaluating certain options like laterals or the high deviated wells or the horizontal wells or the fracs in order to improve the recoveries, because all of these would reduce the drawdown near wellbore, and you could produce at the same rate with a lesser drawdown. That would reduce your condensate dropout. So we are currently initiating that study for this field.
Thank you, Saad, for a nice presentation.
Thank you, everyone.
Next paper is tapered liner hanger system for zonal isolation and hydraulic fracturing and application in Kirthar Fault Belt region. The authors are Syed Asad Abid, Muhammad Azhar Hussain, Muhammad Umar Khalid, Muhammad Azim Sarwar, Shaklaj Sartaj, Hamid Ahmed, Might News Gorinek, Rashid Ali Sheikh, Ibrahim Al Lewani. Syed Asad Abid.
Am I audible? Okay. So thank you so much. I'll be presenting the paper taper liner system for zonal isolation, an application in the Kirthar Fault Belt region. I'll be presenting on behalf of the Polish oil and gas team. So most Kirthar concession wells are characterized as tight gas wells, reservoirs due to the permeability being less than 1 millidarcy. The reservoir formation pub needs stimulation through hydraulic fracturing to enable the well to flow at commercially feasible rates. The wells themselves are located in the fold and thrust well region with the strike slip components, so borehole instability issues due to in situ stress-induced complexities such as weak bedding planes, rubble zones, and fracture through shales, more specifically through Laki and Ranikot shales are very common. So these are troublesome shales to drill through. The shale formations are generally drilled in the 12 and quarter inch intermediate hole section with the high mud weights ranging from 15 to 16.5 ppg. The reservoir formation pub sandstone is then drilled in the 8.5-inch production hole section with a lower mud weight range of about 11 to 12.5 ppg, and then is cased off with a 7-inch liner and subsequently fractured and completed. The issues drilling the pub formations are mostly lost circulation and differential sticking challenges. So it's very critical to have the pub formation drilled separately from the above-lying shale formations. So coming to the well at which the application was used for the taper liner system. So the background was that we drilled a well A, we drilled and cased off the top sections, and then we drilled the 12.25-inch sections with the Rani Coat shale causing numerous issues, mostly related to wellbore stability. The section was then cased off with a 958 casing, and then we drilled the pub formation in 8.5-inch hole with a mud weight of 12.5 ppg. So partial to complete losses were observed during drilling, and the string was observed to be stuck at Viper Trip. Subsequent fishing attempts were made, but they were unsuccessful, and the top of the fish was such that we had no other option but to sidetrack through a cased hole. So this meant exposing both Rani Coat and pub formations in the same hole section. So two subsequent sidetracks were drilled to TD, but we were unable to case it off because in both the sidetrack boreholes were lost. The string was stuck. We had very high mud weight, more than 15 ppg, to stabilize the Rani Coat formation, and losses in differential sticking was observed again in the pub formation, worsened further by high mud weights required to stabilize Rani Coat. The well was then temporarily suspended. So the foremost issue was we could have drilled the pub formation and 6-inch hole separately, but we needed to have a liner system that was capable of sustaining the high frac loads and suited to our fracturing operations. So we evaluated this liner hanger system. If you can see on the right hand side the image of the schematic of the 958 inch into 7-inch into 4.5 taper liner string. So we have the upper PBR assembly, and then we have the 958 into 7-inch slip type hanger segment, and below that we have the provision to run 7-inch liner joints, followed by an inline lower PBR with a seal bore ID of 4.75 inch to be run above the 4.5-inch liner joints. We also had separately a V0 rated seal stem assembly with seal stem consisting of FFK material elastomer seals for stinging into the 4.75-inch seal bore ID, allowing for production through a tieback monobore completion. So for the liner placement, for running in the liner, it's critical to have simulations conducted, because we need to ensure this tapered string we could rotate through wellbore restrictions, and if we had to rotate during the cement job to ensure we had a good cement quality. Also hydraulics were very critical, so we also simulated the hydraulics calculations to ensure that we could get a sufficient flow rate of 4 to 6 BPM while circulating on bottom and also conducting the cement job. So the operations itself are pretty straightforward. We'll come to the benefits of liner hanger later on in the slides, but we drilled the Rani Coat formation and cased it off with a 958 casing. Drilled the 8.5-inch hole. Drilled the 8.5-inch hole and covered Rani Coat with a 7-inch hanger first. Then we drilled the pub formation and we ran the taper liner string. So you can see with the taper liner string, we had the 958 into 7-inch hanger with the 3 7-inch liner joints, followed by a lower inline PBR and then the 4.5-inch liner joints. On the right side, you can see the conventional completion schematic, where we have in the conventional design, basically that was before the application of this tapered liner string, when we would complete the well in the 8.5-inch hole with 7-inch production liner. So the production packer or the frac packer would be set across the 7-inch liner joints. So just a brief on how we conduct the fracturing operations. The hydraulic frac treatment post setting the frac DSC packer is, first we do the breakdown test, then we have a step rate test with step up and step down, then a calibration test or a mini frac as it's known, followed by the main treatment pumping. The critical thing to note here is the surface pumping parameters during hydraulic fracturing treatment. The surface pressures are generally around 12,500 psi, could be less than that as well, but this is what we observe in our fields. And the pumping rates around 20 to 22 BPM with a slurry density of 10 to 12 ppg. After pumping the frac treatment, the string is pulled back to surface, followed by the well completion operation with the appropriate size of tubing selection and downhole completion. So drilling the 6-inch hole, reservoir pump formation in the 6-inch hole, we had to evaluate what appropriate liner system must we run to ensure we conduct our fracturing operations safely. So we had a plethora of options. We could have gone with the conventional 15K liner hanger system with the 4.5 inch into 7-inch liner hanger and the DST packer situated above in the 7-inch joints. But the problem was that in this case, the 4.5 inch liner top would be exposed during the hydraulic fracturing. So in case there's any issue with the liner top packer, there could be a weak path or communication jeopardizing the hydraulic fracturing operation. To offset or mitigate this, what we could have done with the same conventional liner hanger system was the use of tieback seals, just running a tieback seal on a frac string to isolate the liner top at bottom of frac string. The conventional systems available then to us didn't have a lengthier PBR. So we did the tube move calculations and basically figured with the conventional systems we couldn't do the frac operations for the risk of the tieback seals popping out during the injection operations. To further offset this, we could have gone for a mechanical packer or a hold down sub along with tieback seals to restrict the movement of the seals, even with a limited PBR. But then there's this risk of creating a hydraulic lock chamber where it would be difficult or impossible to unset the packer and the tieback seals once we've conducted the operations. Another option would be to run the run the DST or frac packer inside of the 4.5 inch liner. But this would cause minimum ID restrictions. So how we've planned or designed our frac treatment over the years is that we prefer bigger IDs in that to ensure that we deliver maximum proppant and hydraulic fracturing treatment to the borehole. So this would compromise on the overall fracture design and geometry. Thus, we came to the utility of an inline lower PBR with a tapered liner hanger system. So this system essentially, the taper system essentially consists of the inline lower PBR with bottom connections compatible to a 4.5 inch liner and top connections compatible to 7-inch liner. The advantages for this system were for us obvious over a conventional system, where in this system where you can see on the right hand side the DST frac string with the tapered liner string. So the DST packer is located in this 7-inch upper segment of the tapered liner string. So essentially the liner top is still not exposed with this. Also we're not staying in, so we don't have a hydraulic lock chamber issue. So the well integrity wise, there were fewer potential leak paths in this system. There were no minimum ID restraints in terms of the delivery of the frac fluid treatment. So no compromise on the hydraulic fracturing job design. Also no hydraulic isolation chamber issues, so allowing installation of a conventional 7-inch DST frac packer inside the upper segment of the liner system. So once we proceeded with the operations, we run and hold the liner, cemented it. One challenge was the integrity testing of the lower PBR system. Since we had to frac it, we had to test it at a higher pressure and the tieback seal stem, simulating the downhole conditions for tube move and the bottom hole pressures. On the right side, you can see the graph, where basically what we did was at the end of the flex string, we connected the tieback seals and run in hole, and then we stung in the tieback seals into the lower PBR. So we carried out a test at 8500 psi surface pressure using a higher brine fluid. You can see on the graph on the right side that we held the pressure for 30 minutes successfully. And what we did was we increased the pressure in step increments to simulate the tube move calculations for cross verifications. And we we actually, corresponding to the hook load, we verified the tube move calculations that we performed were accurate. So after this test, the seal stem assembly was successfully retrieved to surface and physically inspected. The surface condition was found to be satisfactory of the seal stem assembly. The DST and frac operations were then carried out by setting the packer inside 7-inch liner joints above the lower PBR. And during the hydraulic fracturing operations, the lower PBR was exposed to high burst pressures, and overall system integrity was found to be satisfactory. Coming to the results and conclusions. So this particular system, the tapered 958 inch into 7-inch into 4.5, I believe, with an inline lower PBR, the first one to be run in this country. It allowed us for the PUF formation to be drilled separately in the 6-inch hole section. The tapered liner string with the lower PBR was demonstrated to be a successful liner system, enabling wellbore isolation, hydraulic fracturing, and a monobore completion. It allows for a contingency hole section in case we could go with the conventional system, but since if we face the same issues again, where we don't have any option of a slimmer hole, we can go with this option then and drill it in the 6-inch hole section. The addition of 6-inch hole section also allows for the shale formations to be drilled separately as well. So normally with the Rani Code and the Laki shale in one hole section, this system allows us for them to be drilled separately as well, which is preferred, by the way. In some of the later wells, we've been adopting this strategy. So the future application, another one could be simply conducting the frac using the seal bore stem strung inside the lower PBR without maybe a mechanical packer or hold down slip. There were some challenges as well related to the lower PBR application, tapered liner application, and slim hole section. The length of the inner string during cementing operation is limited to 30 meters. So basically, once we run the liner, the running tool has a tail string attached to it. So we convey the wiper plug inside of the 4.5-inch liner using this tailpipe assembly. So there is a limit to the length of this tailpipe assembly. And as practiced and recommended by a vendor, it was 30 meters. So essentially, if you think about it, we can only run 30 meters of 7-inch liner joints in this. So we could place our packer, we have to place our packer, DST packer, or frac packer, or production packer within this 30 meter. The clean-out operations in the slim hole pose extra challenge in terms of string torque and tensile strength. The conventional wireline BHA can't pass through clean-out BHA. Slim wireline tools would be required. Perforation guns, size limitation due to slim hole. This one was actually not really a big challenge since we could arrange for perforation guns, but our preferred sizes were bigger than that. And there was no standard provision of downhole memory gauges setting during well testing operations due to monobore completion design. However, lately there's been nipple-less gauge hangers available on the market that we can use. So with this, I conclude our paper, and thank you so much for allowing us the opportunity, and thank you to my team, POGC.
The floor is open for the question answer.
Hello.
Thank you very much.
Hello. Yeah, I have a question.
Yes.
Yes, sir.
Regarding the hydraulic isolation, you mentioned between the lower PBR where you inserted the tie-back seal nipple and the 7-inch packer.
I can't quite get where the question is coming from.
It's from here.
Okay, okay.
Yeah, it's
Can
roughly
you
here.
speak out a bit? Can you speak loudly, please?
I was asking about the hydraulic isolation between the tie-back seal nipple and the 7-inch packer. Initially, you highlighted it as a risk, and then your frac string also included the same packer in the tie-back seal.
No, actually, let me clarify this. So the seal stem assembly actually allows us to frac with this assembly in particular, but just because of that risk, we did not include the tie-back seal stem with the DST packer. So there's this option where we can run the seal stem on its own. We tested it initially. It was our plan to incorporate it into the frac operations, but because of that particular risk, we did not run the DST packer or the frac packer along with the seal bore stem.
So you mean to say that the 4.5-inch liner top was exposed to the
No,
frag load?
no. Because the liner top was 958 inch into 7 inch. So the inline PBR is actually just made up of threaded connections. So if you have the DST frag packer placed inside the 7-inch liner segment of the upper PBR, the liner hanger is above that.
All right, I think we can discuss this.
Sure.
offline.
I can. There's more details in the paper, but we can discuss this further as well.
Sure, thank you.
No problem.
Okay, thank you very much. Yes. I think this is a great presentation, and I really appreciate Polish company going for this very challenging area for fracking well and getting all those data. I think this is a great work you did.
Thank you.
Particularly in Kirthar Bulakia, and it's a very good guideline for the people who are going to operate in that area.
Thank you so much.
By just clarification, I'm not going to ask question. The clarification is, what was the sand phase pressure or breakdown pressure at which depth you got?
Sir, I'm not entirely sure if I'm allowed to divulge that information, but a completion engineer perhaps could fill you in on that.
That is important one for us to learn the lesson.
Sure.
Well, thank you, sir, for this question. Actually, the breakdown pressure ranges based on the depletion. So if we are encountering a virgin reservoir, our breakdown pressures are over 8,000 psi, sometimes closer to 9,000 psi.
Breakdown at sand phase? Breakdown pressure, not surface
These
pressure.
are the surface pressures. If we will add hydrostatic, it depends on the depth. It will add up like 4,000 psi more. So downhole, it will be ranging 12,000 to 13,000 psi.
That's good, okay. So what was the fracture off length you determined?
Sir, again, it's a matter of simulations, area to area, pre-frag DSC results, 3D modeling, in situ stresses. So we are targeting sometimes around 300 meters. This is our max that we have targeted and we have achieved. In optimum cases, we are targeting 100 meters to 150 meters.
Okay. So in this well particularly, you got about 300 meters. We can assume?
In this well, the range was between 100 meters to 150 meters because we had different challenges associated with the slim hole, as my colleague has mentioned before. But the 300 meters is the max that we have achieved in this area.
Very good. Thank you very much.
Thank you.
Thank you very much.
Thank you. Thank you all.
Let's proceed to the. Thank you. Let's proceed to the third presentation of this session. The title is the application of United Nations Sustainable Development Goals in exploration and production sector of Pakistan. This will be presented by Mr. Muhammad Naman Khan, who belongs to PPL. The other co-authors are Salman Hamid, Muhammad Asim Mushtaq. Naman, please come over.
Thank you. Bismillahirrahmanirrahim. Assalamu alaikum everyone. As the title of presentation is already communicated to you and it is displayed here, the application of United Nations Sustainable Development Goals in exploration and production sector of Pakistan. So this is the outline of my today's presentation. I will first go through the introduction to the United Nations Sustainable Development Goals, briefly touching each of it and explaining it, and then its relevance and implementation by the E&P sector around the world, and also specifically some examples from international examples and from Pakistan. Then I will focus on some specific examples related to PPL's field, the largest field, one of the largest field of Pakistan, Suigas field, where how these sustainable development goals have been implemented. And being the extensiveness of the topic and these SDGs, they are 17 in number. We will see in coming slides. I will only focus on 3 of the major SDGs, that are good health and well-being, quality education, and clean water and sanitation. This is the introduction to UN Sustainable Development Goals. These goals are as listed here pictorially, and you can read it very clearly that these include 17 goals. If I name them. These are no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, and several others. You can read it here. The details are present also in my paper. So these are the 17 important goals, and these are actually adopted in September 2015 as common universal goal for UN's member states to transform the world into a fairer, more prosperous and peaceful society until 2020. These SDGs actually, you can see with the names that they are actually promoting human well-being, preserve earth ecosystem, recognize the link between poverty reduction, sustainable growth, justice, and addressing climate change. And all these 17 goals are actually interactive partner of each other, and that they all, one or the other way, are actually supporting each other in achieving the objectives. And the benefits emerging from any one may be a future supportive tool for another SDG in some other context. So this is the brief introduction of the SDGs, that is Sustainable Development Goals. Now in the next slide I will focus on these SDGs linked with ENP sector. And just by looking at the names of these SDGs, you may guess that these SDGs are very closely related to whatever ENP sector is doing around the world and also in Pakistan. So you can see they are very well linked with the oil and gas sector. And depending upon the type of operation an ENP company is doing, like during the exploration phase, there may be some other sustainable development goals that a company may be focusing. During production phase, it may be some different. Depending upon the area the ENP company is working, there may be some different SDGs on which a company may be focusing. But either in every case, you can find ENP sector is significantly contributing in these days SDGs, both locally and internationally. So as we will be focusing on the three main goals, just giving a brief on them, that good health and well-being actually like implementing and prioritizing health and well-being of employees, local communities and environment. The SDG number 4, that is quality education, that is actually like in implementation and investing in education, skill development, community engagement, and promoting sustainable practices, as well as collaborating on these items with the local communities and education institutes for having taking other stakeholders on board. Similarly, in SDG 3, clean water and sanitation, it deals with adopting responsible water management practices to minimize water consumption, reduce waste, and prevent contamination of freshwater source. And here we also need to collaborate with the local communities and local governments. There are few examples that I have given several examples in my paper, but I will just show 3 or 4 here just for having a glimpse of how all the ENP companies are contributing in these SDGs around the world. This is taken from one of the reference I have quoted in the paper, that is IFP, IPIC and UNDP mapping of the oil and gas sector report of 2017. And you can see these companies are really contributing in various sectors of education and water and sanitation, and also in terms of health. Coming to Pakistan, there are I think all the ENP companies are very effectively contributing in various areas of sustainable development goals. Maybe they may not be linking their work with these SDGs of UN, but if they work on and they try to find out, there are a lot of work related to CSR and other activities are really linked with these sustainable development goals in different areas. So I have listed some of the companies. This is not the complete list, but just to give a flavor that every company is really engaged in Pakistan in doing this very important area of work. And then I will be focusing in coming slides on some of the PPL's work to give an highlight of how PPL is contributing in this, in one of the largest gas fields of Pakistan, that is Sui gas field. This is just an introduction of Sui gas field. It is located in district Dera Bukti, Balochistan, about 650 kilometers from Karachi, and it has reached its peak production in around 1999 at 900 mmSCFD per day of gas, and it's on its advanced stage of decline. So we can see throughout the life of the field how PPL had contributed to the community, and how these can be linked with the sustainable development goals of UN as being the target of different countries. So this is the general data of Sui field. About 114 wells have been drilled, and major reservoirs are SML, SUL, HR and PUB, and there is about 112 kilometers of feeder line network and about 58 kilometers of gas gathering network. The population around Sui field is reaching currently at more than 120,000 people. There are some difference of opinion on it, but as per census in 2017 it was around 100,000. And now I will just discussing and focusing on the one by one on the 3 SDGs, how PPL has contributed. Good health and well-being, it was well implemented at Sui gas field. These are the 4 areas in which we have worked extensively. There are more areas, but I am focusing on these 4 only, which are the prime ones. Occupational health and safety area, establishment and continuous support to a public welfare hospital at Sui town, and support to local government in healthcare. And very important, the last item I will discuss in detail is the Sui field hospital, which is, I think, is a unique contribution of PPL that we will be seeing in coming slides. In terms of occupational health and safety, these works that I am showing here are, I think, all of the EMP companies, I think, are contributing in this manner. They are taking care of their occupational health and surveillance for the employees, for the well-being of the community, and which include the regular audits for compliance of health, safety and standards. And similarly, Sui gas field is also has international certification of ISO 9001, 14001 and 45001. Continuing it, the public welfare hospital. This is an hospital which is actually governed by the Board of Governor and operated by Government of Balochistan, but primarily it was fully established and equipped by PPL. It is a 50-bedded hospital, fully constructed and furnished and equipped by PPL at about rupees 350 million in 2013-14, and currently it is catering for about 250 patients daily. The facilities include gynecology, emergency operations, theatres, and laboratory and pharmacy. And not only in the construction, but currently and continuously PPL is contributing in the consultant fees, repair and maintenance and facilitation of the inpatient in this hospital. These are the support to local government in healthcare. I think many of the NP companies are also contributing. Similarly, in Sui, we are expanding, supporting government in expanded program for immunization, malaria and other disease control, medicines for DHQ hospital, free surgical eye camps, and providing anti-venom for snake bites in the area. Now I will focus on Sui field hospital, which is I mentioned that's a unique area of work. This was established by PPL in 1956. It started from a dispensary to a fully equipped 55-bed secondary care hospital. It is fully funded by and operated by PPL. and the average annual expenses are around 200 million per year. This hospital provides free medical facilities to employees, partner staff like who are working around us like SNGPL and SSGCL staff, as well as the local community. It is equipped with the latest medical facilities, and here our well-trained staff, doctors and paramedical staff manages advanced laparoscopic surgeries, general surgeries, gynecology cases and other surgical procedures at this facility. So the local community does not need to require, if it is related to these facilities requirement, they are provided with fully equipped machineries are there. You can see a glimpse of here is that this is an operation theatre where laparoscopic surgery is being performed. There are 2 operation theatres in the Swifield Hospital, and we have very well-trained surgeons present there. Similarly, there is a 24-hour emergency department and trauma and accident patients, and all kind of different types of emergencies which may be very critical in case of transporting this patient to farther areas like bullet injuries and mine injuries. They are all handled and managed at hospital, and made these patients, if required for an ICU, they are prepared the patient for traveling to this far away locations. This is just a glimpse of how PPL Swifield Hospital is contributing. About in the last 15 years, 10,000 major operations have been carried out and 4,000 minor operations, and emergency services are provided to more than 200,000 persons, out of which about 60,000 were non-employee. And in case of disease prevention, vaccinations were provided, including COVID-19 and hepatitis B vaccine. About 6,000 births are managed at the hospital. That is really a unique thing, I think, in a hospital at the field area. And the cost incurred on non-employees in the below table, it's about 200 million rupees in the last 3 years. And just focusing on the last 1 year, we have treated about 5,500 patients and carried out about 800 surgical procedures, out of which 50% were non-employees of PPL. Now we will come to the second SDG, that is quality education implementation. PPL played a key role in changing SWI education culture and improving literacy rate by providing free education to the PPL employees, kids, and the nearby community. And these contributions include higher professional education, scholarships, and support to federal government, livelihood generation. But the most important thing is that I have written in the end is there a SWI model school, which is also a unique thing, that PPL is operating 100% constructed and owned and operated complete school that is actually educating not only the employees, kids, but also the kids of the community living around it, if the seats are available there. So these are the statistics. You can see about 3,000 students are enrolled at the school now. 40 qualified teachers are working there, teaching the students, and about 1,250 about 2,000 students have passed out from this school, 10th grade, and 427 girls have been passed out their 12th grade exams. So this is a great contribution to the area in terms of education. And the last is the clean water and sanitation, which is the SDG number 6. And in this SDG, PPL has been providing water not only to its own area, because this area, when the field was discovered, there was no water source around it. So PPL identified 57 kilometer away an area where water can be arranged, that is at Khiwali, which is in district Rajanpur in Punjab. And there is a 57-kilometer line was laid, and a pumping station was established at that location, which is actually contributing and currently supplying 3.4 million gallon of water, which is the only prime source of water in Sui area. And out of this, only 23% is being utilized by the PPL operational needs and its employees, and 77% is actually being supplied to the local communities, LEAs, and other associated people who are living around for their living. So this is a great contribution by PPL in providing the water supply to this area. Now I will conclude my presentation with these concluding remarks that PPL's effort in Sui gas field aim to demonstrate its commitment in preserving the area biodiversity and improving living condition of the local residents in line with the UN Sustainable Development Goals. And the presented data demonstrate the extraordinary efforts and contribution made by PPL toward improving the quality of life for local community with a voluntary spirit in challenging environment. And in the last, these efforts can use an example for motivation of the E&P sector, which is also contributing a lot to support the country in implementing the 2030 agenda of UN Sustainable Development Goals. In the end, I acknowledge PPL management to allow me to present this paper, and also the relevant staff of Sui field who provided this data and helped me in preparing this paper. Thanks.
Thank you. Thank you, Raman, for an interesting presentation. We can have only 2 questions because of scarcity of time. Please go ahead.
Thank you very much. It's a very good work that PPL is doing. Very much appreciated. I want to ask one question that these programs are more relevant like CSR programs. And the name SDGs, it came under the umbrella of ESG, Environment, Social Governance. So would you like to elaborate what is the link of these SDGs with ESG and CSR programs? Thank you very much.
This may need a very long time to explain it, but I will try to cut it short. That as I explained in my first and second slide, that these SDGs, which are 17 in number, are actually interactive partner of each other. So if we are working in CSR, so we may be covering some aspects of these SDGs. So they are all linked. But why we are focusing on this, that because it is internationally agreed at UN level that every nation who is the member of UN will be taking care of it, trying to implement it. So this paper is actually just to make a link between E&P sector of Pakistan with these SDGs. We are working a lot, no doubt, but with the name of, as you have mentioned, ESD, ESR, CSR activities and other. But that is the just point of thinking for all of us, that all E&P companies can link our work with these SDGs. That will really help in our government and Pakistan to recognize our efforts at UN levels by linking it. So this is one of the purpose of this paper to present here.
Last question, please.
Assalamu alaikum. As you showed the 70 years of journey of PPL in Balochistan, but the quality education institutions are very small. Only one institution which you showed that is established in it is requested that more quality education institutions may be established in Dera, Bhukti and other areas of Balochistan and also in Sindh, Kamba, Shadadkot district.
You are talking about Educational Institute?
Yes.
Okay. So you are right. This is not the end of the world. This is the effort that I am showing is actually efforts done by an E&P company, right? And there are a lot of more you can find in my paper also. So we can take this as an example, and we can all combinedly strive to do some more thing. There is always a room for improvement. But what we are seeing here, that can you quote any example of E&P company operating a school at its field for its employees 100% and for in the community around the area? So this is an example. Yes, there is more area of improvement. We should go for an university. We should go for a more higher education. I agree with you. Lekin this is a start, and we all collectively can think that we can contribute more in this area.
Thank you.
Thank you, Raman. Thank you.
Fourth paper is from Sprint. Enhancing wellbore integrity for well subject to fracturing, strengthening, cement sheet, flexural strength, and
thank you very much.
Ensuring long-term cost effectiveness, well integrity. This is the case study. The author is Syed Hamza Ahmed. Co-authors are Arif Yusuf, Ramiz Anwar, Kashif Shahzad, Syed Sarjeel Ahmed, Javed Iqbal, Sameer Mustafa Noor, Irfan Nazir, Samar Noman, Syed Hamza Ahmed.
Good afternoon. The topic of today's presentation is enhancing the well bore integrity for the well subjected to hydraulic fracturing operation. So the term hydraulic fracturing is quite a familiar term that is used for production optimization operation. In this particular operation, the fluid is pumped on the wellbore with the increased fracture pressure. Since this particular operation has high economic value, so the cement behind the casing needs to be evaluated before performing the hydraulic fracturing operation. So this is the brief background of the presentation that we will discuss in the next 10 to 20 minutes. And I will now like to introduce towards my author panel. So this is our author panel. Myself is Syed Sarjeel Ahmed, and this is my team who are the co-authors for this research paper. So this slide basically covers the agenda, that what are we discussing in this presentation. First of all, we will start with the introduction, then we will cover the key challenges, then we will move towards the job design and stress modeling, and then we will have a comparative analysis between conventional cements and the flexible cements. And then we will move towards the job execution, and at the end we will draw down the conclusion. So first, in this section, we will discuss that the hydraulic operation has some post-job impacts which covers the compromised wellbore integrity, mechanical failure, sustained casing pressures, which is quite a common problem, and hydrocarbon channeling. So here a question arises that what is the solution for this problem? So the solution for this problem is flexible cements. The flexible cements tend to improve mechanical properties, and there are some key features of flexible cements, which includes flexible particles, which has a fracture toughness and higher tensile strength. Then it has a key feature of low Young modulus and high Poisson's ratio. So in this slide, we will discuss about why flexible cements are a value addition in the oil and gas industry. So we have a beneficial impact of flexible cements, like they provide long-term zonal isolation due to the factor that it has sustaining elevated downhole stresses. Then it has durability. Then it provides opportunity that a greater working window can be used and a vast hydraulic operation can be performed on the well. And the last one is easy operation. Basically, we don't need any additional mixing equipment to perform this sort of job, and this is a plus point of flexible cements. So I will discuss the key challenges of this particular job that we had conducted in the southern region of Pakistan. The first challenge in that particular well was hole cleaning and mud removal. For performing any cement job, the hole cleaning and mud removal bears a great importance. So while performing the job at the southern region of Pakistan, it had a challenge that it had irregular hole geometry due to large washouts in the 7-inch section, and from the caliper log we had evaluated that 9.09 inches was the hole diameter. So in order to have a good hole cleaning, we proposed well wash, the surfactant based solution, and we had incorporated spacers so that we have a good and effective hole cleaning. The next challenge was the casing centralization. As I told you before, that the hole had a caliper log of 9 inches, and the minimum standoff requirement that is recommended by API is 67%. So considering this, we had a challenge that we had maximum centralizers OD of 8.25, and it yielded a centralization of 39%, which was low as compared to the recommendation. But we had incorporated an optimized centralization plan, and we had also incorporated liner rotation to improve the displacement efficiency and radial coverage for the cement operation. Then we had a challenge of short-term integrity, like preventing of gas migration during the transition phase, like we had trip gases observed during the tripping operation. And for this particular purpose, we incorporated right angle set slurries, which has a low transition time from 30 to 70 BC. Then we had a requirement of compressive strength development, that compressive strength development should be rapid within 24 hours at the top of liners. So in order to enhance this particular compressive strength, we had incorporated compressive strength enhancer like microsilica, and we had achieved the desired amount of compressive strength. Then there was another challenge like creation of microalloy that we usually observe due to negative differential pressure, and induced microalloys can form. Similarly, depending upon the exposure and pressure temperature variation, we had a problem that microalloy can be created in the wellbore. So for the purpose to mitigate this particular challenge, we had incorporated the expansion additives so that our slurries can expand after being placed at a particular depth. After that, there was a key challenge that was cement failure under dynamic stresses. So the cement failure during dynamic stresses is quite common, and in order to overcome this challenge, we had utilized flexible cement, and with the help of these, we had overcome the challenges that was considered. So basically, once we had the challenges covered, we then proceeded towards the stress modeling, and we had conducted stress modeling on a software, on a simulation software that was SemLife, and it basically indicated that we had no issues while stress modeling, and our designed cement slurry was effective for a particular challenge. So after being simulated, we then moved toward the laboratory analysis, in which we had conducted different types of tests that are usually associated to perform any cement job. We had performed thickening time tests, then UCA tests, then SGS tests, and then we had evaluated the mechanical properties. You can see by the help of graph that we had proposed almost 6.5 hours thickening time for the job, whereas the total time that was required was 145 minutes. We had included the safety factor while designing the job. Similarly, the table shows that we had a rapid compressive strength around top of liner. Like in 12 hours, we usually get 1400 psi approximate, and for 24 hours, we had 2200 psi. Similarly, we also conducted critical gas strength test at bottom of static temperature. The graph can depict that the designing parameters. Once we had achieved all the laboratory analysis, then we moved towards the mechanical properties, and we had performed expansion ring test for the expansion properties of the cement. And during the interval after 1, 2, 3, 7 days, 15 days, we had a total expansion of 0.83%. So in this table, we had a comparison between flexible cement and the conventional cements, and the flexible cement yield the properties that were desired for the candidate well. So the job execution. The job execution was that we had conducted a cement job at Ghotki region of Sindh in a 7-inch casing job and 8.5 open hole drill section. So the job was conducted as per the planning, and you can see from the table that we had achieved that what we had planned, and we had successfully achieved the planning phase because the cement job depends upon the construction phase. And similarly, that it is important to have a good planning before proceeding towards the job. So these are the basic job results that we had gathered, and we had performed a successful cement job considering the flexible cements, and we had performed ultrasonic imaging tool log, and then we had also have an image that you can see with low amplitude, and we had strong formation signals, and also we had a radial coverage around our zone of interest. So moving towards the conclusion, I think that flexible cements are a game changer to oil and gas industry, and by the help of it, we can perform effective planning for the wells that are subjected to be subjected to hydraulically fractured. It provides wider window for performing fracturing operation, and it reduces the NPT and chances of workover operation. Similarly, the return on investment is really good, and it gives a wider window to perform production optimization operation. So this is the end of the presentation. If anyone have any question, then he is more than welcome.
The floor is open for the question answer. Only 2 questions. No question?
This is Zaman, and my question is related to hole cleaning. You mentioned you pump, well wash and spacers, but what specifically in the design which make it different from the other spacers?
Basically, the well wash solution was a surfactant based solution that is usually pumped to have a good bonding between casing and the formation. It is surfactant based, it usually cleans up the casing well enough, and then the spacer provides good effective barrier between the cement and the native fluid. So basically, to have an effective hole cleaning, we had proposed a surfactant based well wash that was creating an impact that was used as a pre-flush.
Hi, over here.
Last question.
So, yeah, the last question. So you mentioned that the application is for fracking the wells. For the UCS values that you quoted in the slides, you said the slurry properties go up to 6,000 psia, but the actual frac loads are probably much higher than that. I understand that the UCS that you have obtained from the results is from the unconfined tests, but how do you cater to the fact that the actual fracture propagation pressures are much higher than what the UCS is? I mean, Is there a mechanical test? Does the mechanical testing, such as Brazilian testing, cater to that, or do you use software simulations?
Basically, to cater your question, we had simulated first about the hydraulic stresses, that what hydraulic stresses that we will get while performing the job, and based upon those hydraulic stresses, we had simulated or we had gathered the mechanical properties that the cement would achieve. So basically, considering the compressive strength, we usually incorporated expansion additives, which creates some sort of expansion in cement, and during the process of cyclic stresses, the cement expands, and we had a provision to sustain those sort of stresses. So by the help of simulation and then by the help of designing, we have achieved those properties.
Very good presentation. Thank you very much.
Thank you.
Thank you. Due to scarcity of time, we conclude this session with 4 papers. The 5th paper was supposed to be presented will be done in the next session. Thank you.
So it's the end of the first session for today. Now it's time to present the shields to the authors and the co-authors for the papers as a small token of appreciation for their hard work. The shield will be presented as aligned with the papers being presented today for the first session. I will request the chair and the co-chair, Mr. Sharik Ali Hashmi and Mr. Mia Akram, so please come forward to present the shields for the authors and co-authors. The paper that is presented first today was Optimizing Well Placement and Recovery in Mature Gas Condensate Reservoirs through the Utilization of Pseudo-Pressure Approach. This paper was presented by United Energy Pakistan Limited and the author being Saad Mahmood. I request please Mr. Saad Mahmood to come on stage for the shield. Co-author Mr. Muniz Iqbal. In the absence of any co-author, author is please requested to take the shields. Saad Mahmood, Mr. Muniz Iqbal, Abdul Azim, Saddam Hussain, and Mufadil Murtaza Zakir. The second paper presented today was Tapered Lionette System for Zonal Isolation and Hydraulic Fracturing, an application in Keithar Ford Belt region. The paper was presented by PGNIJ Pakistan section. I would request Syed Asad Abid to please come on stage to receive the shield. Muhammad Azhar Hussain, Muhammad Umar Khalid, Muhammad Azim Sarwar. The third paper presented today was Application of United Nations Sustainable Development Goals SDGs in Exploration and Production Sector of Pakistan. Paper was presented by Pakistan Petroleum Limited. I will request Mr. Muhammad Numan Khan to please come over to collect the shield. Salman Hamid, Muhammad Asim Mushtaq. The last paper presented for the session 1 of day 1 was Enhancing the Wellbore Integrity for Wells for Subjective to Fracturing, Improving Cement Shield Flexibility and Ensuring Long-Term Cost-Effective Well Integrity, a case study. Paper was presented by Sprint I will request Sayyid Sharjeel Ahmed to please come on stage to receive the shield. Sayyid Hamza Ahmed, Samir Mustafa Noor, Irfan Nazir and Ramiz Anwar. Now I will request Mr. Imran Qureshi to please come on stage.
उनको स्टेज पे बुलाएं, सेशन चेयर को चेयर की स्टेज पे भी बुलाएं। उनको बताएं।
We will request Dr. Jadoon to present shields to the session chair and co-chair. Thank you, Sharik Saab. Thank you, Mia Akram Saab. So this concludes our session, and we very, very quickly move on to the next session. We have a small session, which is how to attract investment in E&P sector, key steps and best practices. I would like to introduce David Barrowman. He is the Vice President, Global Head of Fiscal Consulting with Woodmac. He has over 40 years in industry, specializing in fiscal advisory, licensing rounds, and investment support. He advises governments, companies, and industry associations across the globe. He's a fellow Institute of Chartered Accountants and Chartered Tax Advisor. Jurisdictions benefiting from his consultation include Alaska, Algeria, Australia, Bangladesh, Canada, Colombia, Greenland, Indonesia, Ireland, Kazakhstan, Lebanon, Qatar, South Africa, UK, and Uzbekistan. So as we are running a little late, I've tried to make it very quick, and I would like to call David to take over the stage. No, just tell them to go to the next slide.
Ah, okay. Fine.
Somebody over there is sitting very attentive.
Okay. Good afternoon. It's a pleasure to be here speaking to you today. As was mentioned, I'm David Barrowman. I work for Wood Mackenzie. And what I want to do is really to discuss with you about the things that governments need to think about when they're trying to attract inward investment. And this, whilst this is certainly an issue for Pakistan, I think some of the things that I'll say today relate more broadly across governments. Next slide, please. I just wanted to spend a minute explaining Wood Mackenzie. I think quite a few of you may have heard of Wood Mackenzie and have worked with us before, but I just want to explain Wood Mackenzie is a leading consulting firm, we focus very much on energy and natural resources. We've got a large number of clients across the globe, and we deal with oil companies, we deal with majors, independents. We also deal with national oil companies, governments, and financial institutions as well. And what that does is it provides us with an understanding of what different parties are looking for. We understand what industry wants, and we also understand what government needs. I think if we can go on to the next slide, please. The Energy Minister in his talk this morning discussed the issue of energy transition, and I mean, it certainly is the primary challenge facing the upstream oil and gas industry today. I mean, it's not just relevant clearly for upstream oil and gas, it's relevant for all of us, regardless of whether we're in the industry or not. What the chart here shows, on the left-hand side we've got oil demand, and the right-hand side we've got gas demand, and we show it from 2000 up to 2050. And what we're able to do using WoodMac research databases is to have a look at the range of uncertainty on demand for these two products. And on the oil demand side, you can see there is a lower line, and the lower line is based on the Paris Accord, the 1.5 degree increase in temperature. And it shows quite a steep decrease. I think, unfortunately, there is a realization amongst most people, and certainly the scientists as well, that have said that it's unlikely that we'll manage to keep the rise in temperature to 1.5 degrees. So the upper part of the range of uncertainty shows what the situation's likely to be if we manage to limit the increase in temperature to 2.5 degrees. So there's a pretty broad range of oil demand outlooks, and clearly oil demand is going to drive oil supply, and this is going to have an effect on what needs to be produced. Certainly we can see oil falling, but under the 2.5 degree one at a much slower rate than the 1.5 degree case. If we look at gas demand, we've got similar lines, 1.5 and 2.5 degrees. The fall in gas demand is much less than it is for oil demand. The reason being is that gas is very much seen as a transition fuel. It's replaced, in some cases, coal, and certainly longer term, we'll see gas replacing oil in part as well. The reason for this is that the carbon intensity of gas is much less than that for oil, for a similar energy volume. I think just to make another point about the energy transition is really to think about what companies are doing. And we've seen over the last several weeks and months some interesting approaches being made by the industry. We saw in the last 2 to 3 weeks Exxon and Chevron making $60 billion purchases. And they purchased Pioneer Natural Resources, Exxon did, and Chevron purchased Hess. And I think they are signaling that really upstream is not going to end anytime soon by making those acquisitions. We've also seen BP and Shell announcing that they are slowing the commitments they made to energy transition, certainly in the short to medium term. So again, we're seeing the energy industry recognizing that we will need fossil fuels for a significant time to come. I think the death of upstream oil and gas has probably been slightly exaggerated, although we will start to see a decline probably from 2030. Next slide, please. And if you hit again. what we're showing, sorry, just stop here, thanks. What we're showing is here, just wanted to think about what the key issues for the international oil industry is. And I've divided the, what the key areas are really into two categories. One is what governments cannot control, and the other is what they can control. And I think one of the key things that governments cannot control is what's in the rocks. What does a subsurface hold? If there is no resource down there, then really there's no chance of developing an oil and gas industry. However, what governments can do is they have tools and levers to encourage the industry to come along, to explore, to determine whether there are commercial subsurface reserves. If you could move on, please, and then just hit it once, please. Thank you. So if we think about what governments can control, governments can certainly play an important role, as I mentioned, in helping companies understand the potential of an area. And I think we heard that, very interestingly from Mr. Al Marzuki this morning, who mentioned what ADNOC had done, spending $2 billion really to encourage the industry to come in. Now, clearly not every government has $2 billion to spend, but there are other things that they are able to do. I mean, there was another example where Nova Scotia, one of the Atlantic provinces in Canada, spent several $1 million having a play ferry analysis done really to work out what had happened in the subsurface over tens of millions of years. I think in terms of what governments can do, they can do studies, they can help in studies being done. They can also do things like share existing data to ensure that companies have all of the available information that will help them make decisions. And I think one of the things that is important is really giving companies information means that they can make informed decisions. If you can hit this one more. Thank you. Companies, when they're making decisions, they need to feel confident that they are going to achieve their target returns. And, for example, this may be economic thresholds, so it may be what's the internal rate of return that they can achieve from a given opportunity. It may be something like payback, because it certainly is important for the industry to get its money back early. It doesn't want to be sitting there taking 10, 15 years to get its money back. If you could hit the button one more time, please. One thing as well about fiscal regime is it should not deter investment. We do see around the world quite a number of jurisdictions where if you look at the returns being made before the government takes its share in the form of taxes, profit share, that these are commercially viable projects, but after the government takes its share, then they're unprofitable. And certainly fiscal regimes should be taking a share of the upside, but they should not be turning otherwise profitable projects into unprofitable ones. And if you just hit the button one more time, please. Another key issue that needs to be considered, and this really applies in jurisdictions across the globe, is the regulatory environment. And sometimes we see countries with great fiscal terms, but the challenge they have is the regulatory environment. And I think there's always going to be challenges in having the perfect regulatory environment, but it should be straightforward. It should be as simple as possible. It should be transparent so investors can understand what they're facing, and it should be efficiently managed. And that will allow, quick decisions to be made. So there are a number of things that the governments can control to encourage inward investment. Next slide, please. What I wanted to do, I mean, there was an interesting comment made by the Energy Minister this morning who was talking about the reduction in exploration that had taken place in the last few years in Pakistan. These slides here really show that Pakistan is not alone in having the exploration, the amount of exploration activity reduced. On the charts, on the left-hand chart, what we show is the amount spent from 2013 to 2022 in terms of exploration budget, and that's on the bars. I will skip over what is on the lines and just focus what's on the bars. So the exploration spend on the left-hand chart is the cash value. On the right-hand chart, we can see the number of wells that have been drilled. It's apparent from both charts that there's been quite a significant drop from 2014. And if we think back, oil prices 2013, early 2014, over $100 a barrel. Everyone is confident they're going to remain at that level. And then from mid-2014, they started moving down and collapsed. And that led to an initial reduction in the level of exploration activity. However, the level of exploration activity has remained low. And in part, this is due to companies not really reinvesting so much in the upstream, that they are being companies are being rewarded by their shareholders by doing things such as having share buybacks and increasing their dividends. So there are other drivers at play. What we're expecting to see is exploration isn't dead. We're expecting to see a bit of an uptick. And anecdotal evidence suggests that in 2024, we're probably going to see a rise of about 15% in cash terms, which if one knocks off about 5% for inflation, it's probably going to mean about a 10% real spend. If you could just go on to the next slide, please. Another issue that we looked at is the amount of license rounds. And really, the issue is, you know, as Pakistan, you're clearly not alone. There are a lot of other jurisdictions having license rounds as well. You can see that the number of rounds was low, peaked pre-pandemic, and then has dropped back quite a bit. The areas where rounds are being made do tend to change through time. But I think if one thinks about really what oil and gas companies are looking to do, they're very much looking to high-grade their portfolio. They want to get rid of unprofitable projects. They're also focusing on projects with high carbon intensity. And you can certainly see companies trying to get rid of those, because what they want to really have is a leaner, cleaner portfolio, and they want to get rid of non-core and disadvantaged opportunities. As I mentioned before, especially on oil assets, they're looking for rapid payback. And, you know, there's a lot of uncertainty if you're an oil company in what the returns might be, what might happen to the price. So they want to get their money back as quickly as possible. On gas developments, it's much harder. Revenues tend to be spread out over a longer time. And really, for gas developments to be attractive to the bigger players, they need to be either of such a size that you can produce LNG. And, you know, you're talking about a few TCF of gas that you need to have for that to happen, or somewhere where they're going to make adequate returns from the local market based upon what the gas pricing structure is. And then just finally on this slide, given the increased energy transition focus, there's also another driver for getting your returns quickly that you don't, I mean, if you think about the timing, if I'm a company, I go into a license round tomorrow and I'm going to go and drill unless it's something that is outstanding, say like Guyana and possibly Namibia, it may take several years before I make a decision to develop. It may take a few more years to develop the asset. So it could be 10 years on, at which point the energy transition may be sort of in full flow. So what companies will be doing, again, is really wanting to get their money back pretty quickly, driven by energy transition concerns. And then just the final slide that I have, if we could just move onto that, please. Don't worry, I'm not going to discuss all these aspects. It's really just to highlight what is going on in the world in terms of fiscal discussions. And the bottom line is there's a lot going on. This is really just what's been going on in 2023. Some are concluded, some are still ongoing. If we go back a year or two as well, there's been a lot more discussions. And I think, you know, the key trends from that are that we've seen, certainly in Europe, there's been a lot of windfall taxes due to the price spike caused last year by Russia's invasion of Ukraine. So on the one hand, industry has been taking some of the upside. On the other hand, we're seeing with more marginal developments, money being given back to the industry to encourage some of these types of developments, less profitable developments. And also we see on the energy transition side, with regard to carbon capture spending, that they are starting to be allowed for relief in the spend anyway, is being allowed for relief in upstream PSCs. I've really just got sort of one or two final points to make. And the first one is, I think you all know it, it's a competitive world out there. There's a lot of other governments looking to entice investment from oil and gas players. Companies have a lot of choice, but they don't have unlimited funds or unlimited resources. So they're going to be high grading where they go to. What governments need to do really is to differentiate themselves. What makes Pakistan attractive compared to other jurisdictions? Why is the international oil industry going to come here? And the one thing that governments do have, as we discussed already, is that they have several levers that they can use. And governments do need to consider what levers to use and how they use them. That concludes my talk. Thank you very much for staying. I know you've had to delay having lunch, so I'd just like to say thank you very much to everyone who remained. I don't know if you want to do questions or if everyone just wants to go and have lunch now. Okay. I mean, happy to. Yes. There's one.
Thank you very much. It was a nice talk, an eye-opener for us all.
Thank you.
I would just like to have a very simple question. Do you have any kind of, do you rate the countries according to their investment environment, whereby you're comparing especially the government offerings that they have, and how good is an investment compared to a country X versus country Y? Do you have any kind of studies that go around with that?
Yes, I mean, these sort of studies are very much the cornerstone of what Wood Mackenzie does. We've got a lot of analysis on our research side that we produce and sell to the industry. And we analyze pretty much all the main producing assets, upstream assets, worldwide. So we can use that database to do comparisons. But specifically to answer your question, what we do have is we've got fiscal research analysis, and within that, what we can do is compare the returns that investors make and governments make between each other. We use model fields, and then we'll run those model fields, and we can show how different regimes compare. And in terms of the regulatory environment, it's certainly something that we've done often on one-off consulting projects for government. So certainly we do have a huge amount of that information. Yes.
Hi, thank you. Wood Mackenzie covers a lot of exploration bid rounds, and just wanted to check with you if you can share one or two key reasons for a success or a failure of an exploration bid round. Because we have seen quite a few in Middle East, in North America, in other places, South America. So what were the key reasons in your view that contributed to the success and likewise to the failure of an exploration bid round?
Yeah, that's quite a challenging question, but I will do my best to respond. I suppose there's really two issues, and the one issue that I highlighted earlier is what's in the rocks. And it's very much what's the perception of what's in the rocks. And you know, we see you know, some countries or some parts of the world that are only now starting to come forward, that you know, companies didn't really bother about them before, but sometimes what you need is maybe a major just to, you know, sometimes these majors will drill 5 or 6 wells that don't really have any sound economic basis, but they'll just do it just to see if they can find anything. So you've got that. You need to, certainly the companies need to have confidence that there may be something there generally. But I think the other thing is really ease of doing business and what information is getting provided. I think it's things like, you know, has, you know, seismic been drilled in the area? Is it well understood? And what type of seismic? Are we talking 2D, 3D, or what? So this kind of goes back to the other point of having the data, having the information. So each license round is going to be unique, but I think there will be things, and I think it's part perception, part information, and then companies will still look at the economics and think, you know, are we going to make money here? So I don't think there's one killer answer to it. There's a lot of things feed into that. Okay? Okay. Thank you.
So thank you very much, David, for a very good session. This concludes our session for now. We have one session, a student session, finishing in about 7-8 minutes. So lunch will be served after 10 minutes. Thank you very much for being a very, very good audience. Thank you.